talk about determinants of a 3 by 3. Again, there's a nice equation. However, it's a little long. So we have our first column A's, second column B's, third column C's. So you can see that. There you go. And what you do basically is this is what you do. Let's say I want to talk about the value of A1. What you do is you say, okay, A1 is in the first row, so cross these items out. A1 is in the first column, so cross these items out. So what do I have? I've got A1, okay, A1 times, and this again, this is talking to you about how you're going to find the determinant of a third order. Let me scroll here, okay, so we can combine them together. So what we do is we say, okay, A1, cross the items that are left, find the determinant of. Well, the determinant of that is B2 times C3 minus B3 times C2. So you've got the A1, B2, C3, and you've got the minus, negative, A1, B3, C2. Okay? And you go about this in all of them, okay? Now you have a subtraction symbol. Put your subtraction now. Talk about the values of the A1. You say, all right, well, A1, A2 is here, right? We'll cross out this row and this column and take the determinant of what's left. Then we have a plus, and this is how we come up with our equation here. So if you ever forget the equation, no worries, because we can figure it out by simply taking the values, cross, determinant of what's left. Take the next A2, cross, take the determinant of what's left. Last, take A3, cross, take the determinant of what's left. Don't forget the middle term, get the subtraction symbol in front of it. And this is how we come up with our equations. Now, we can always, let's see, okay, now, we can always do determinants in our calculator, which we talked about before, talking about, edit, put your matrix in, go to the math, go to determinant, okay? So now we're going to talk about 3 by 3 determinants. We're going to do them by hand, but we're also going to do them in the calculator. Let's find the determinant of this 3 by 3 using our equation for determinant. Okay, now this is A1, A2, A3, B1, B2, B3, C1, C2, C3. Let's write out our equation of the determinant of a 3 by 3. I have A1, B2, C3 plus B1, C2, A3 plus C1, A2, B3 minus A3, B2, C1 minus B3, C2, A1 minus C3, A1. Okay, we have 3 positive terms and 3 negative terms, and that's how you can check to make sure that you have all the terms written down. Now let's plug in. A1 is negative 2, B2 negative 1, C3 0, plus B1 is a 1 times C2 negative 2, A3 is a 3, plus C1 is a 0, A2 is a 1, B3 is a 1, minus A3 is a 3, B2 is a negative 1, C1 is a 0, minus B3 is a negative 1, C2 is a negative 2, and A1 is a negative 2, minus C3 is a 0, A2 is a 1, and B1 is a 1. Anything that has a 0 in it, obviously 0 times anything goes away, so anything that has a 0 in it goes away. Okay, so all that we're left with is a 1 times negative 2 times 3, or negative 6, a negative, 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 that's positive. A 1 times 2 times 2 will get you 2, 4, okay? And let's make sure. Yeah. So that this would just give you a -2 as your determinant. Let's see. Minus. I just want to check my negatives here real quick. So let's see. Yes, C2 is negative, and that's positive, and that's okay. And that one's, oh, sorry, B3. B3 is actually a positive 1. Okay, sorry, there's my mistake. Which means that this would actually give you a negative. You guys probably already saw that when I was writing it down. Okay. Sorry, that was a positive 1 for B3. B3 is a positive 1, which means I've got negative, negative, negative. That means that this would be a negative. Negative. 2 and 2 and 1, that's a 4. -6 and -4, that's -10. Alright, now, you can always check your work with your calculator, which is how you know whether or not you got something right. So let's check our work. I want to put this matrix into my calculator. This is a 3 by 3. Put in your values. Okay. Then I'm going to go back in the matrix under math, under determinant. I'm going to pick up the matrix that I just made under names, and I'm going to hit enter. Notice that it says the determinant's -10, and we got the determinant's -10. So you can always double check your work. If you are just using the calculator for it, always make sure you put your data in right, otherwise it will be incorrect. Let's talk about Cramer's rule for solving a system of linear equations in 3 variables. Cramer's rule is a way of using determinants to solve your system of equations. So for example, if you have a system of equations, 3 equations, you've got an x, a y, a z, and an answer. What we do is we simply say, the first equation, there's an a1, a b1, a c1, and a d1. The second equation, we have an a2, because it's the second equation, b2, c2, d2. The third equation, we have an a3, a b3, and a c3. So basically now what we have is our system of equations, a1, b1, c1, d1. That's our first equation. So what we do when we have an example is we simply line these up, find out what a, b, and c are. So, Cramer's rule basically divides your system of equations into separate matrices. For example, for the third order determinant, what we do is we find capital D. Capital D is the determinant of, now remember, if you have absolute value bars around a matrix of numbers, it's asking for the determinant of it. So it's saying that capital D is the determinant of your A's in the first column, your B's in the second column, your C's in the third. Basically, it is the determinant of the coefficients of the variables x, y, and z. dx, it's saying you want to replace the A's, okay, with your D's. So it says replace the x coefficients with the d coefficients. The D's go here, the B's stay, and the C's stay. Again, the determinant of that. For dy, you want the determinant of the A coefficients stay where they are, the B coefficients, however, change to the D's, and the C coefficients stay where they are. D sub z is your A coefficients stay where they are, the B coefficients stay where they are, the C coefficients get replaced with your D's. With using Cramer's rule, if your capital D determinant here is 0, then at least one of the determinants in the numerator is not 0. The system is inconsistent. The solution set is the null set. Please make no mistake, this is the null set. Okay, not 0, but null set. Okay? Let me get a pen. The null set. It looks like a 0, but it has a slash through it. That's the null set, empty set, inconsistent, no solutions. If your D equals 0 and all of the determinants in the numerators are 0, then the system of equation is dependent. It has infinitely many solutions. Okay, so again, if this determinant, capital D, is 0, and at least one of the determinants in the numerator is not 0, then it's no solutions. If, however, your capital D is 0, but all of the numerators are 0, then there's infinitely many solutions. And you might be wondering, well, what do I mean by numerator and denominator? Cramer's rule gives you solutions for x, y, and z. X is dx over capital D, y is dy over capital D, and z is dz over capital D. So let's look at an example using our new rules for Cramer's rule. Here's my matrix that I have, my system that I have. So what I want to do is I want to change this into a matrix. So -2, 1, be careful. This one has an x and a y, this one has an x, a y, and a z, and this one has an x and a y, which means I need a placeholder for my z. Okay? I don't know if you can see that. Let's do this. So I've got my -2, my 1, my 0, my placeholder for the z. I've got my A and S column here as well. Now, answer column here would be the 1. Okay. For the next one, I've got a 1, a -1, a -2, and a 2. And lastly, I've got a 3, a 1, a placeholder, and a 6. Please be careful, okay? You need those placeholders. Okay, so if I want to use Cramer's rule to solve this, basically, I need to figure out D. I need to figure out D sub x. I need to figure out D sub y. And I need to figure out D sub z. Okay? Well, capital D is the determinant, or the determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. D sub x is the determinant of D1, D2, D3, B1, B2, B3, C1, C2, C3. D sub y is the determinant of A1, A2, A3, D1, D2, D3, and C1, C2, C3. And lastly, my D sub z, A1, A2, A3, B1, B2, B3, D1, D2, D3. Alright. Okay. The value of x is determined by finding D sub x over D. Alright. Well, D sub x is the determinant of my D values in my first column, 1, 2, 6. My B's in my second column, that would be 1, -1, 1. My C's in my third, 0, -2, 0. Divided by my capital D determinant. The A's in the first, the B's in the second, and the C's in the third. -2, 1, 3, 1, -1, 1, 0, -2, 0. We can find these determinants in our calculator, or we can find them by hand using the equation mentioned earlier in the video. Since we've already talked about the equation, I want to show you how we can do this using our calculator. I'm going to matrix and I'm going to edit. I'm going to make 1, 2, 3, 4 matrices. Okay? The first matrix is a 3 by 3 matrix, the D matrix. -2, 1, 0, 1, negative 1, negative 2, 3, 1, 0. That's my D matrix. Next, I'm going to scoot down to B, okay? Now I'm going to make, again, a 3 by 3, but this time it's going to be my D sub X matrix. So that's a 1, a 0, a 6, a 1, a 0. No, I'm sorry. Looking at the wrong column here, my bad. 2, negative 1, negative 2, 6, 1, 0. Okay, double check my numbers real quick. Alright. Okay, now I'm going to make my, scoot down to C. I'm going to make my D sub Y matrix. Again, it's a 3 by 3. I've got my negative 2, my 1, negative 2, my 1, my 0. A2 is 1, D2 is 2, C2 is negative 2, A3 is 3, D3 is 6, C3 is 0. And lastly, I'm going to scoot on down to D. I'm going to make my D sub Z matrix. So I've got my A, negative 2, 1, 3, my B, 1, negative 1, 1, my D, 1, 2, 6. Okay? Now, what I want for X is I want dx divided by D. Now, in my matrix, D was A, D sub X was my B matrix, this was my C matrix, this was my D matrix. In my calculator, okay? So, what I want is I want to go into matrix and find the determinant of dx, which in my case was the second matrix. Always make note and remember which matrix you name what. The determinant of this matrix dx is negative 10. I want to divide that by the determinant of D. So I go into matrix, go over to math, pick up determinant. My A matrix is my first matrix here. That would be negative 10. So negative 10 divided by negative 10 would give me a 1. Okay, so that's the value of X. So X is 1. I need to know what Y is, and I need to know what Z is. So let's go ahead and figure out what Y is. Y is D sub Y divided by D. D sub Y will be the determinant of negative 2, 1, 3, 1, 2, 6, 0, negative 2, 0. On the bottom is the same denominator that we had before, the D matrix. Okay, so again, I know the denominator is negative 10, but let's figure out what the numerator is. I now want the determinant of my D sub Y. My D sub Y was in my C position in my matrix. So scoot on down to C. That says it's negative 30. So I have negative 30 divided by negative 10. That means it's 3. That means Y is 3. Last, I want to figure out what Z is. Let's get another piece of paper. So now Z is D sub Z divided by D. So D sub Z, using my equation here, plugging in my values, D sub Z is negative 2, 1, 3, 1, negative 1, 1, 1, 2, 6. Okay? Divided by the determinant of my capital D, which again is the same denominator. Again, we know the denominator is negative 10 because we've worked it before. So let's go ahead and figure out what the determinant is of, and this time I'm going to look at, in my matrix, this was the fourth one. Oops. I want the determinant of, go back into matrix, scoot on down to D. That says it's 20. So that means I have 20 divided by negative 10, so that would be at negative 2. That means Z is negative 2. So my system of equations here can be solved by 1, 3, negative 2. Now remember, if the problem simply wants you to solve the system, keyword solve, if you see solve the system, okay, this is keyword for your calculator. You can use your calculator if you have it for RREF. Again, you can always do everything by hand since we're talking about both. So what I want to do is I want to go into matrix and I want to build this matrix. This matrix is a 3 by 4. And I'm going to put my values in here. Negative 2, 1, 3. 1, negative 1, 1. 0, negative 2, 0. 1, 2, 6. Now if I simply want to solve this, solve the system, that's RREF. RREF. Back into matrix, under names, pick up the matrix I just made, and hit enter. Notice that this is spitting out the solution for me. It states that the solution is 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 3, negative 2. Remember, your first column is your x, your second is your y, your z, and your answer is your last. Well, what does this first one say? 1x plus no y's plus no z is equal to 1, or x equals 1. Oh, that's what I got, using Cramer's rule. Next, no x plus 1y plus no z equals 3, or basically y equals 3. Well, that's great, because that's what I got, using Cramer's rule. Last, this says no x, no z, or sorry, no x, no y, 1z equals negative 2. Basically, z equals negative 2. Well, that's great, because that's what I got, using Cramer's rule. Again, if the problem simply says to solve the system using Cramer's rule, you can use Cramer's rule, or you can simply use your calculator to save yourself some time. You'll get the same answer.